Hello, guys. I hope you all are doing well. Welcome back to this amazing channel, which is Geeks for Geeks Practice. Myself, Abhinav Avasthi, and today this is the 23rd day of our 30 days streak in this Geeks for Geeks Practice channel. And we will be discussing again three more problems of Geeks for Geeks SDE Sheet. And we will have three problems in homework today too. Okay. So I hope that my voice is clearly audible to you all and we are good to go. Just write a +1 if I am clearly audible to you all and so that we can continue. Today, the problems which I have taken, the topic which we are focusing on will be binary search tree. So there are three problems and all the three problems are of binary search tree that I have taken. Okay. I hope that you all have checked it. Just write a +1. If, yeah, I have Margaret, Ernest, Nakaj, Jatin, Subham, Sachin, others. Hello to all of you. And for all others too, if you are here, just write a +1 so that I can know that you have joined. And also hit the like button so that the like count should just be equivalent with the number of viewers. Seeing of a lot of time. By the way, I am placed in Paytm. Thank you. Okay, congrats, Sneha, for your placement. Congrats a lot. Okay, great, guys. So I think now we can start. Okay, great, guys. So let me just first share my screen. Okay, so that you all can just check that. Okay, okay. Just a minute. Okay, great. Yeah. So first of all, for those who are high centers, for those who are beginners, जिन्हें नहीं पता है binary search tree होता क्या है, for them, I'm giving a brief intro about binary search tree. That what is a binary search tree, and all the three problems that we will solve today are also just around this binary search tree concept only. Okay, so let's first take the first problem and let's see how we can solve that problem, which is search in a binary search tree. But before that, let's see what is a binary search tree. Okay, so let me first also open my second problem, which is validate BST. Okay, that's the next problem, which is check for BST. Okay, and here we will see that the definition of BST is defined. You will see this is the definition of BST. So a BST, a binary search tree, is defined as it has some properties. The left subtree of the node contains only nodes with keys less than the node key, and the right subtree of the node contains only nodes with keys greater than the node key. And both left and right subtree must also be a binary search tree. So this is what binary search tree is. Okay. So let me explain you guys with the help of example. Okay, how we can understand it binary search tree. So it is saying, let me also take a case. I think I was having a case here. I have taken an example for you guys so that I can explain you that what is that binary search tree. Okay, great. So let me also add a banner. It's binary search tree. Okay, great. Thanks, Shubham. Thanks. हाँ ये मैंने दिवाली में बैकग्राउंड किया था. Hello, SKOBIDUBISIGHT. Hello. I can't pronounce that, so I just spelled it. Okay. So this is the root. Okay, I have not shared my screen. Just a minute. Yeah. So here this is the root. So root means this is the origin. What's the root? Root is the origin of a tree from which a tree is originated. So this is the root of the tree. Now, what is meant by binary search tree? If you will see the definition of it, it is saying the left subtree of a node contains only one node with key less than the node key. So, according to this binary search tree concept, it is saying that the left subtree of the node contains node which is less than that. Contains node which is less than that. So, if this is the root, so this all is its left subtree, or you can say its left node, and these are the right nodes of it. These are the right nodes, and these are the left nodes. There is a confusion between students. What they think is that we are just talking about the left and right children, but no, we are talking about the complete left subtree and right subtree. Is it clear? Right or plus one? Is it clear? कि एक रूट के लेफ्ट की जितनी भी नोट्स होंगी वो उससे छोटी होंगी, एक रूट के राइट की जितनी भी नोट्स होंगी वो उससे बड़ी होंगी. Getting? This is what binary search tree is basically. And you will see every subtree of this binary search tree is also a binary search tree. Just write a one. Just write a one in the chat if this is clear. Okay, this main property of binary search tree. Just write a one. Okay. What happened here? I'm not getting the responses. One. If it is clear that what is a binary, that the property of binary search tree is write a one. Okay, Subham, you are not able to upload your resume. I will check it. I will ask the team to check that thing. Okay. Okay. Great, guys. Obviously, that is the obvious others. If I'm saying that the left should be less than the root value, that is the obvious thing. Ki root will be greater than the left value. Okay. What I'm saying, the value of root should be greater than the left subtree values, and it should be less than the right subtree values. Okay, that is what it is, which is left subtree, root, and the right subtree. Okay, great. Now, guys, the next thing which you have to observe. Okay, so this is what binary search tree is. This is the basic definition of a binary search tree. Okay, now the next thing is, or you can say exactly. That's what it is. Okay. I don't think that in binary search tree there are equal values. So there are always distinct values in a binary search tree. Okay. So you can say duplicates are not allowed. We are assuming that duplicates are not allowed. Okay. So guys, you will see one thing. Why it is called binary search tree? It is a simple binary tree. But why it is called a binary search tree? What is a binary tree? A simple binary tree is which has at max 2 children. So that property is also fulfilled here. Means this particular tree will have at max 2 children. That is completely fine. But one more thing is there. The extra thing is that this binary search tree, by research, because of this condition, which I've told you, that the root value should be greater than left and should be less than the right. That is the root value. There is a range basically. There is a range for each node. कि जो एक नोड की वैल्यू है वो उस रेंज के बीच में ही हो सकती है। अभी हम लोग अगला क्वेश्चन करेंगे जो कि होगा चेक फॉर बाइनरी सर्च ट्री, वहां पर हम लोग उस रेंज का भी यूज कर रहे होंगे। फॉर नाउ लेट्स सी हाउ वी कैन सॉल्व। यस, some BST doesn't permit duplicate keys exactly. Okay, there is a different case of binary search trees are there, different modifications are there where we can use that, but here we can't. Okay, now guys, the next thing. Okay, let's see one thing. This is what is given to us. Now the first question which is asking us is nothing but this search node in a binary search tree. So it is saying that we are given with a binary search tree and we have to find the node which has the value x. So we have to just, I think, output true and false. Yeah, we have to just output 0 and 1. 0 means that node is not present. 1 means that node is present. That's what the problem is. Is the problem clear to everyone? Is this first problem clear to everyone? So that we can discuss how we can solve it. Okay, great. Okay. Now guys, just see one thing here, that this is the root. Now, if we have to search a value from this root, it is just like binary search. Just like we have implementation in binary search, similarly we have here also. The difference is just binary search is implemented on sequential data structure like vectors, arrays, but this binary search tree is a tree structure, hierarchical structure there. Others, I have already shared the link in the description of all the 3 problems, but then also I'm sharing it in the chat box. Okay, no worries. So now let me update with this binary search tree. So search a node in BST, that is our new okay, great. Exactly, Smith, that is what we will do. Let's see this thing. Okay. So just see one thing, that if one minute, yeah, what is it? Okay. So yeah, this is our root. Now, if we have to find, okay, if we have to find a value which is greater than this node, एक वैल्यू है जो इस नोड से बड़ी है, so where that value will be? That will be on the left subtree or that will be in the right subtree. Means I am saying that if, let's say we are searching for a value x, we have to search for a value x. So if x is greater than this root value, so it will be in the right side, exactly. So where we will go? We will traverse towards the right side. But how? How? Just like we do traversal in linked list. We write na? We write like head is equal to head dot next. A pointer is there. A pointer named next is there. So we have some 31 people now. First of all, guys, if you have joined, please remain in this session for the complete next half an hour, or means till 11, because we are going to cover some important topics related to binary search tree. Also, you can like our stream so that others can also join, so that our reach will be good. Okay, great, great, guys. So this is what we have now. What we will do, simply write root is equal to root dot right. Else if x is less than root value, so obviously root will be equal to root dot left. We will go towards the left side. And else means that x is equal to a root. In that case, we will simply return true. we'll simply return true. That yeah, our answer for this test case is true. That is the only thing that we will do. Okay, is it fine? Is it correct? Is it clear to everyone? Okay, great. So now let's solve the problem. Let's solve the problem. Okay, and please guys, please help me to solve the problem. Okay, so here this is what we have. Fine. So what we will do that while our root is present, while root means while root is not equal to null, till then, while root is not equal to null, what we are doing that if the current root value, or I think that we call it data here, yeah, in GFG it's data. If current root data, or you can say if x, the value which we are searching for, is equal to our root data, so we will simply return true. That yeah, it is present. Else, if that data is greater than root, if it is greater than root, sorry, I was just writing C++ code, oh sorry, Java code. In Java, it's just like dot. Sorry for that. Okay, great. If it is greater than, so we will move towards the right subtree. We will move towards the right subtree. Okay. So for the right subtree, we will simply write root is equal to root right. Else, what we will do? Else I will write left subtree. Okay. And after it, if for no value, this condition will be true. So we will simply return 0. Or you can say false. Okay, let's compile it. Great. Yeah, for this it is the answer is right. Let's submit it. Yeah. So we have got the right output for this particular problem. Okay. So this was the first problem. I've taken this problem because I know very many of you are beginner here. So I just wanted to start from a very basic problem of binary search tree so that you guys can have idea how binary search tree works. Okay. So fine. So if this problem was clear, there are some 20 people watching now. Please write a +1. All of you, so I can know that yeah, this problem is clear. And then we will move towards the next problem. Okay, great. Next problem is quite important. If we talk about the on the side of interviews, then also it is important. Okay, that's also very important. Fine, great. So great, guys. I hope this problem was clear to everyone. Now let's move towards the next problem. Just give me some time to open it. Okay, till now, guys, just please tell me क्या चल रहा है अभी तक? कॉलेज कैसे चल रहा है? क्या चल रहा है लाइफ में? How the things going? किसी एग्जाम्स वगैरह आने वाले हैं क्या? अभी इस वीक चल रहे हो या आने वाले हो? कोई ऐसा? Okay. Okay, I'm a working professional in December. Yeah, I actually have 2 exams. I have a midsem this week month only, which is from 17th of November, and then end sem from 17th of December. Okay, मेजर प्रोडक्ट ग्रेट. सो व्हाट इज द टॉपिक ऑफ योर प्रोजेक्ट? मींस किस टाइप का प्रोजेक्ट बना रहे हो आप? प्लेसमेंट नहीं लग रही है? अरे लगेगी यार, सबके लगेगी विशाल. ऑल द बेस्ट फॉर प्लेसमेंट्स. NLP class threats. Okay, great guys. BCA semester 1 exams. Okay, great. Fifth sem started. Okay, yeah, same. My first sem has also started. Not now. It's 3 months, I think. Yeah, means actually, मेरा क्या है ना कि I have 3 exams uh, in next 3 months. No, means one of the exam has been done. If you remember that in the start of the series, जब series start हुई थी, my exams were going on. That was from 17th October. Now I have my midterms from 17th of November and then end from 17th of December. Lot based self-driving car. Okay, okay, great यार. आप कौन से कॉलेज हो भैया? मैं HBTU कानपुर. It's a state university in Kanpur. You are in first semester of BCA. Great, Nakas, great. Great, guys. Great. Same using recursion, or what will be base case? Yeah, recursion can be done. Base case will be that if root is null, so we will return 0. अगर root null हो जाएगी तो हम लोग 0 रिटर्न कर देंगे. ये होगा बेस केस. और अगर रूट हमारी x के इक्वल हो जाएगी तो फिर हम लोग 1 रिटर्न कर देंगे. ठीक है, ये हो जाएगा हमारा बेस केस. डोंट वरी अबाउट द बेस केस. ओके, डोंट वरी अबाउट द बेस केस. Great, guys. Great. Now let's calculate that thing too. Okay, let's calculate that. The next thing, the validity. Thanks, Vishal. Thanks very much. Thanks very much for it. Okay, great, guys. Let's start with this now. I think that now we can start. Please hit the like button. Okay, and then we will start with the next problem. Hit a like so that I can know that we can start with the next problem. Okay, great. So let me update the panel with the problem. Yeah, I am currently in my 5th semester. Subhasis. Subham base case. Okay, great, guys, great. So yeah, this is the next problem, which is check for BST. We are given with a binary tree and we have to check that whether our binary tree is a binary search tree or not. Every binary search tree is a binary tree, but every binary tree is not a binary search tree. Every binary tree is not a binary search tree, but every binary search tree is a binary tree. Okay. So you are given with a binary tree and you have to check whether that is a binary search tree or not. Binary. Okay. So what are the conditions for a binary search tree? What are the conditions? Yeah, Subhashis, I am 2024 pass out batch. Yeah, that is the first way, which is the in-order traversal. How? If the in-order traversal is in a sorted manner, that means that the given BST is a valid BST. But that is the very obvious case. And वो सब लोग जानते हैं कि अगर हम लोग in order निकालेंगे एक binary search tree का तो वो sorted होगा. कुछ नया ट्राई करते हैं, कुछ मजेदार ट्राई करते हैं, ठीक है। हमारी प्रॉपर्टी थी हाउ टू जॉइन जीएफजी, जस्ट चेक आउट द कैरियर्स पोर्टल ऑफ जीएफजी, दैट्स ऑल। हाँ, तो this is your binary search tree and this is your root. Okay, no, we can use level order traversal, but let's try something new. Okay guys, guys, now let's stop the other discussion। देखो मैं बीच में 1-2 मिनट के लिए आ जाता हूँ, so that तब तक मैं मतलब आता मैं इसलिए ताकि मैं तब तक मैं जाके अपना प्रॉब्लम दूसरा तैयार कर लूँ और मैं थोड़ी बातें कर लेता हूँ। बट एक बार प्रॉब्लम फिर से आ गया, आपको फिर से उसी मूड में आ जाना है कि अब प्रॉब्लम करना है, ठीक है, बाकी बातें छोड़ना है। फाइन, this is the thing, we have to check for a valid BST that whether a BST is valid or not. This problem is asked in different companies including Amazon, Goldman Sachs, Microsoft, Samsung and many other companies you can see. So let me also include the tag of it. Okay, it is asked in different companies. Now if you will see guys, this is our root. Okay, what we will do guys, that with the root we will take a range. What is the range? A minimum and a maximum. Minimum maximum means what can be the minimum value that node can be and what can be the maximum value of that node. Exactly, we can check lower bound and upper bound for each node. Exactly, this is what we have to do. Exactly. Okay, let's see guys. So currently just assume that for this its minimum is int max. Okay, int min, and its maximum is int max. इसका रीजन क्या है? जो आपके रूट है वो कोई भी नंबर हो सकता है। आपके रूट में तो कोई भी आप देख सकते हो, आपका जो मेन रूट होगा, हेड होगा, जो आपके ट्री का रूट होगा, वो कुछ भी हो सकता है। उसमें कोई भी कंडीशन नहीं है कि इससे बड़ा हो, इससे छोटा हो, कुछ भी नहीं। इट कैन बी एनी नंबर फ्रॉम इंट मिनिमम टू इंट मैक्सिमम। उसके बीच में कुछ भी हो सकता है। आपका रूट हो सकता है, नहीं हो सकता है। क्लियर है? इतना क्लियर है? +1। ओके, नाउ गाइस लेट्स मूव टुवर्ड्स द लेफ्ट साइड। So this is the left side. Okay, so इस लेफ्ट साइड में एक कंडीशन आएगी, the condition will be that this left should always be less than the root। जो रूट थी ना आपकी 25, उससे हमेशा छोटा होना चाहिए। So here what we will do, we will update the maximum value। मिनिमम वही रहेगा जो रूट का था। So minimum will be min only, int min, but maximum will be 25। और वी कैन से मतलब हमेशा 25 से कम होना होगा, 25 या उससे बड़ा नहीं हो सकता। So this is its range। Similarly, if we will go towards the right side, so maximum कुछ भी हो सकता है, maximum can be any value, but minimum should be at least greater than 25। 25 से बड़ा ही होना चाहिए। समझ में आया? Is it clear? +1 everyone, all the 24 who are watching now, +1। Okay, now similarly if we check for this node, ठीक है, let's move to the left of it। So left means, just assume that left means that maximum will be changed, and right means minimum will be changed। Okay, so left में जा रहे हैं मतलब जो मिनिमम है वो 25 होगा, कि 25 से तो बड़ा ही हो, क्यों 25 से बड़ा हो? क्यों 25 से बड़ा हो? क्योंकि ये 25 रूट थी, उसके राइट में है ये, तो 25 से तो बड़ा होना ही चाहिए, उससे छोटा हो ही नहीं सकता, रिस्क ले नहीं सकते उस चीज का। और इसके लेफ्ट में आ गया है 36 के, तो जो मैक्सिमम है वो 36 हो जाएगा, मतलब 36 से छोटा होना चाहिए। तो रेंज होगी 25 से 36 के बीच में। दिस इज हाउ वी विल चेक दिस थिंग फॉर द कंप्लीट बाइनरी सर्च ट्री। इस पूरे बाइनरी सर्च ट्री की हर नोड के लिए हम लोग ये चीज चेक कर लेंगे टिल अंटिल हम लोग नल तक ना पहुंच जाए। एक बार नल पे पहुंच गए, फिर हम लोग सीधे सीधे रिटर्न कर देंगे वन। वन का मतलब क्या है कि हमारा जो बाइनरी सर्च ट्री है वो ट्रू है, मतलब उसने सारी नोड्स के लिए ये कंडीशन जो है सेटिस्फाई कर ली है। बट इफ अगर कोई भी ऐसी नोड हुई जहां पर इफ देयर इज अ नोड जहां पर जो रूट की डेटा है, द डेटा ऑफ द रूट इज ग्रेटर देन मैक्स और रूट डेटा इज लेस देन min, return exactly Nakash. That is what we have to do. Exactly. Okay. Is it clear? If it is clear, just hit the like button. We have some, I think, 23 likes. Now let's make it 50. Let's make them 50. Oh, great. Okay, Subham. We will think of it. I will pass your suggestion to the team. समराइज कर दो एक बार, या देखो मैं समराइज करता हूँ, ठीक, हिंदी में करता हूँ विक्टर आपके लिए। तो हमारे पास एक रूट है, हमारे उस रूट से हमने उस रूट के लिए एक रेंज रख दी, उसका मिनिमम उसका मैक्सिमम, कि उस रेंज में डेटा होगा वो मिनिमम से बड़ा होगा, मैक्सिमम से छोटा होगा। जब हम लोग राइट में जाते हैं, तो राइट में जाने का मतलब क्या है कि जो वैल्यू होगी राइट की वो हमेशा हमारे रूट से तो बड़ी हो, हमारी रूट से बड़ी हो वैल्यू हमेशा, जब भी आप एक नोड के राइट में जाते हो। तो इसका मतलब जो उसका मिनिमम होगा वो रूट हो जाएगा। मिनिमम देखो 25 हो गया, क्यों 25 हो गया? क्योंकि अब वहां की वैल्यू हमेशा 25 से बड़ी होनी चाहिए, 25 से हमेशा बड़ी होनी चाहिए, क्योंकि 25 के राइट में है ये। जब लेफ्ट में जाएंगे तो मैक्सिमम हो जाएगा रूट, क्योंकि वैल्यू जो है रूट से छोटी होनी चाहिए। तो मैक्सिमम हो गया 25, सो दैट वैल्यू जो है रूट से छोटी हो गई। दो कंडीशन होगी, एक होगी मिनिमम के लिए, होगी मैक्सिमम के लिए। ओके, दैट्स द थिंग। इज इट क्लियर? ग्रेट। नाउ लेट्स सॉल्व द प्रॉब्लम। ओके, so we will have a recursive approach only. Okay, so for that let's take another let's say check bst, in which we'll have a simple a node will be taken or a root। स्पेस तो बच जाएगी, रिकर्सिव स्पेस ही होगी जो होगी, और स्पेस तो बच जाएगी, ठीक है। पहले मिल लेते हैं। The values will be in that range। okay, तो सबसे पहले तो हमारा एक आएगा बेस कंडीशन आएगी इस रिकर्जन की, इफ इफ our root is null। Okay, then what will happen is simply return true। एक चीज और, यहाँ पे हम लोग कॉल करेंगे ना इस वाले फंक्शन को, so it will be return check bst रूट कॉमा मिन की जगह क्या आएगा, इंट मिन इंट मैक्स. ओके ओके, दिस विल बी डन. ठीक, अब देखो व्हाट विल बी द रूट डेटा. अब देखो यहाँ पे, सॉरी यहाँ पर देखो क्या आएगा, ये नोड है. अब फॉल्स कब होगा, फॉल्स कब होगा, इफ आर रूट डेटा is less than min, or if our root data is greater than max. उस केस में क्या होगा, रिटर्न फॉल्स. ओके, एल्स व्हाट वी विल डू, एल्स हम लोग क्या करेंगे, हम लोग दो कंडीशन रखेंगे. ठीक है, एल्स वी विल हैव टू कंडीशंस गाइस. क्या दो कंडीशंस होंगी, एक होगा लेफ्ट के लिए, एक होगा राइट के लिए. जब हम लोग लेफ्ट में जाएंगे तो मैंने क्या बोला था, हम लोग हमारे मैक्स को चेंज करेंगे, राइट में आएंगे मिन को चेंज करेंगे. अब देखो एक थोड़ा सा मैं चेंज करता हूँ, चेंज ही करेंगे कि देखो मिन का मैक्स मतलब क्या होता है कि उतनी वैल्यू मैक्स जा सकती है. तो मैक्स को रखते हैं रूट -1, जो रूट की वैल्यू उसको -1 मतलब 24. अब मिन को रखते हैं रूट -1, यहाँ भी रूट +1. इसका मतलब क्या हुआ कि मैक्स मतलब 24 तक जा सकता है, 24 के ऊपर नहीं जा सकता है. और मैक्स में यहाँ पे मिन में मतलब 26 के नीचे नहीं जा सकता है, 25 कभी नहीं हो सकता. ठीक है, आई थिंक वी शुड गो फॉर लॉन्ग मैक्स एंड लॉन्ग मिन. कांस्टेंट्स एक्चुअली नहीं दिए हुए हैं, so I don't think it will work. If it will not work, we will see. Okay, or we can take it. No worries. At the last, what we will do, we will return. ठीक है, we will return, or we can call it like this: Boolean check right. Check right means check for the right side of it. So in check right 2, what we will do, we will call this function check BST only, but for the right side. So root right. In right, I was saying min was changed. Min will be changed to root +1. So min will be changed to root data +1, and max will be as it is. Similarly, we'll do the same thing for check left. So we'll go towards the left side, and here, okay, sorry, yeah. So this is what we are doing. So now here, the max will be changed and min will be as it is, and max will be changed to like this. The value cannot be greater than root -1. Okay. At the last, we will return simply here check right and check left. Okay. Now if you will compile it, okay, it is giving something wrong, I think. Exactly. If anyone is false, it should be false. I don't know why it is giving false or wrong answer. Let me see. Actually, everything is fine. Everything is fine. Why it is not giving the right answer? Can anyone help me with that? Let's make it int only here. Yeah, that is just because of that small int and long, it is giving the right down answer. Okay. Yeah, great. We have solved the problem successfully. That constant is int only. Okay, that is why the problem was there. Exactly. Is it clear or not? Okay, great guys. Just write a +1 if it is clear. It no Shubham, it will not be less than equal to greater than equal to. Why? Because as I told you, equal values are not required. Equal values are not should not be there. And Asu, and because both the conditions should be true. Means on the right side also the values should be in the range. On the left side also the value should be in the range. It's not just about the right or the left. Both the sides. Okay. Great. Guys. So yeah, just give me some time for checking the next problem. Then we will move forward. Which is the third one? हाँ भाई नेकच बताओ यार. Just a minute guys. Till then बताओ यार. अच्छा सब लोग everyone comment out your college, your semester, your branch. Your college, your semester, your branch. Comments पढ़ लो. We can directly assign root data, right? We can directly assign. I'm not getting it. root में minus plus क्यों हुआ? डायरेक्टली असाइन कर सकते हैं बट है ना, मैंने क्या बोला कि वहां मैक्स तक ले आना कि उसको माइनस कर दो तो उससे कम ही हो, उससे कम, उससे बड़ा ना हो. इक्वल हो सकता है, बड़ा ना हो. या आई एम अ कॉलेज स्टूडेंट. आई डोंट नो सुभाषीज की व्हेन द ऑन कैंपस प्लेसमेंट विल स्टार्ट. जादवपुर यूनिवर्सिटी फोर्थ सेमेस्टर सीएससी. ग्रेट. कल ही बताया था, आप पक्का भूल गए होगे. अरे यार हाँ मैं भूल गया सच में यार, सॉरी. सॉरी 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 सॉरी. मैं भूल गया. आप एक बार चेक करना, आप एक बार चेक करना ड्राई रन करके. आपको समझ में आ जाएगा। ग्रेट, KIIT DKT, ओके, चित्कारा यूनिवर्सिटी, ग्रेट, बीकानेर टेक्निकल, ओके ओके। आई एम ऑल्सो शेयरिंग माय लिंक्डइन, जस्ट अ मिनट, मैं शेयर कर देता हूँ। You guys can surely connect there. Yeah, great guys. So now I think that we can start with the next problem. No? Now we can, I think. Yeah, just a minute. And then we will start with the next problem. Okay. Great. Great. Okay, Nuggets. VGM College of Engineering. Rohit, please don't compare this, but working professional continues for GFG course coupon. I badly want that to learn CPP, coding Python. Okay, Subham, okay. You are popular in LinkedIn. You guys are making popular. I'm not popular. Yeah. Okay. Great. Let's start with the problem, which is kth largest element in BST. Now binary search tree. Okay. That's the next problem. It is asked to in Microsoft and Amazon. Okay. Great guys. Great. So in order traversal. So आया नहीं मतलब पहले अप्रोच पहले से पता होगा, सारी क्वेश्चन अपन लगा के रखें, अप्रोच पहले से अपने को आती है, ठीक है। वो तो रिवाइज करने आ गए इस स्ट्रीम में, चलो ठीक है। तो हाँ, इन ऑर्डर ट्रेवर्सल जो है यूज होगा, बट रिवर्स इन ऑर्डर ट्रेवर्सल भी यूज, ओके। अ रिवर्स फॉर्म ऑफ इन ऑर्डर ट्रेवर्सल भी यूज, ओके। अब व्हाई रिवर्स, देखो। अच्छा मुझे बताओ एक बार मुझे बताओ कि दिस इज अ बाइनरी सर्च ट्री, ओके। दिस इज अ actually there's a method, but Nakat, in this today let's solve using this one only, okay, using this in order to, okay, because the thing is now I don't want to go that much complex. You guys can just explore the other ways to solve the problem too, but in this life I don't want to go more complex because there are beginners too. At the end of some people information how to start a CP and how to learn this. Okay, sure, Vishal, okay, sure. Exactly. So we will use reverse in order traversal. So what is in order traversal? First we go towards the left subtree, then we go towards the middle, and then the right subtree. Let's do it with first right subtree, then root, then left subtree. Now guys, why I'm saying that? Okay. So just tell me this thing. If we will find in order traversal of a binary search tree, if we will find the in order traversal of a binary search tree, what will be the output? What is the order of the output? Is it a sorted order, increasing order array? It is an array which is present in non-decreasing form or not? Is it an array with non-decreasing form? Exactly. Which is when you will first take left, then middle, then right. But if we will reverse this thing, first we will take right, then root, then left. Then also the array will be in sorted order, but this time in decreasing order. And that is what we want. If we have to find the kth largest element in an array, So let's say if the reverse in order of this tree is written to us, which is nothing but 48, 40, 38, 36, 30, 28, 25, 22, 20, 12, 10, 5. This is the reverse in order traversal of this given tree. If I have to find the fourth largest number, so I can just check that 36 is the fourth largest number. Just by accessing the reversed in order traversal, we can do this thing. Getting or not? Getting? Now let's see how we can achieve this thing. How we can achieve this thing. Okay. So, guys, what we will do? Fine. Let's say that we have to find the largest number. Let's talk about largest number. What if we have to find the largest number of our binary search tree? So what we do? Rightest node. Okay, rightest node. Fine. This is what is fine, and we will just move towards the right of the tree. That is what we are doing in this reverse in order traversal too. First, we are going to the right side. But with that traversal, as we will go towards the right side, we will do one more thing. We will also have a check on a counter. There will be a counter which is C, let's say C is 0 in start. And this C will have a counter always. Okay. And this counter will basically denote the kth largest element. Let me write a pseudocode for it. And using that pseudocode, we will understand. Okay. Let me write the pseudocode and then we will understand what we have to do. Fine. So let's have an example. Key. This is the diagram which is given to us. Okay. I will write the pseudocode in just beside it. Okay. Exactly. So what we will do, first of all, what we will do, this is the root. This is the root. Okay. Now, guys, what we will do, first of all, we will go towards the right of it. Okay. So because it will be a recursive function. Okay. So let's say the recursive function is just simple, which is kth. So let's say kth node where we will have a root. And we will have the value k. The k means the kth node and a c. So initially this c will be 0. वो ठीक है शुभम, वो ठीक है, बट लेट्स सी टू सॉल्व इट इन कांस्टेंट स्पेस. कांस्टेंट स्पेस में कैसे होगा? एरे ले लेंगे तो एक एक्स्ट्रा स्पेस है, वो तो बहुत इजी हो जाएगा ना, फिर तो कुछ है ही नहीं. ठीक, लेट्स ट्राई टू मेक इट मोर एफिशिएंट. ओके, दिस इज द kth node, root k comma c. Now the base case. The base case will be that if our root will be equal to null, or if c is greater than k. If c is greater than k, or you can say greater than equal to k also, okay, that will fine. Means if it will basically range, it will return. Else what we will do, first of all, just like we do in order traversal, first of all, we will call recursive for the right subtree. So right subtree call will be there, kth node root right k comma c. C will not be updated. Listen guys, C हम लोग increase नहीं करेंगे because यहाँ पर हम लोग इस root को consider नहीं करने वाले हैं. After this we will initialize, we will increase the value of C. Now the case will be that if C is equal to K, so we will simply output our root data and we will return. Okay, and we will return. After that, we will do for the left subtree. Now, guys, let's dive in this. Maybe you are confused. Okay, so let's say the value of K is 4 here. Okay, the value of K is 4 here. We have to find the fourth, which is 36. So first of all, let's take a Q. In this Q, this will be a recursive queue. So first of all, you will see, guys, कि ये जो हमारा ये वाला जो right sub tree वाला जो recursion है, that will go up to the most rightest node. Till then, this will go. When it will reach this rightest node, it will be null, and that will return. After that, what will happen? It will increase the C, and वो जाएगा लेफ्ट नोड की तरफ. तो जब वो यहां पर होगा, वो क्या करेगा? वो पहली बार हमारा C को इंक्रीज करेगा. पहली बार हमारे C को इंक्रीज करेगा, पहली बार. ठीक है, बिकॉज ये जो है, ये हमारा, सॉरी, पहली बार नहीं करेगा, सॉरी. तो पहली बार तो यहाँ पर करेगा ना, जब लास्ट में जाएगा. भाई यहाँ पर इसने सारे, देखो मैं बताता हूँ क्या होगा. ठीक है, मैं बताता हूँ. फर्स्ट ऑफ ऑल, इट विल रीच द एंड में आ गया. आफ्टर एंड इट व्हाट इट विल डू, इट विल इंक्रीज द C. नाउ C विल बी 1. नाउ इफ, अगर हमने पहला लार्जेस्ट, मान लो K की वैल्यू 1 होती, तो हमें 48 आउटपुट करना होता ना. इफ C विल बी इक्वल टू K, वो 48 को आउटपुट कर देता. ठीक है. एल्स वो क्या कर रहे हैं? एल्स वो, यहां पर मैंने गलती से राइट लिख दिया, एल्स वो लेफ्ट सब ट्री में जाता. एल्स वो यहां से इस, देखो ये C2 होता है यहां पर, और जब लेफ्ट में जाता तो C3 होके जाता. क्यों? क्योंकि यहां पे C इंक्रीज हो गया, तब लेफ्ट वाला कॉल हो रहा है. समझ रहे हो? तो ये 3 हो जाता. और फिर जब बैक ट्रैक करते हैं लोग रिकर्जन में, बैक ट्रैक, तो यहां जाके C को 4 कर देता. आप लोग जब इसको लिखना ना, तो आप डीबग करना कि किस नोड के लिए C की वैल्यू क्या दे रहा है, वो किस कॉल के लिए C की वैल्यू क्या आ रही है. इस तरीके से वो फोर्थ नोड पे जाके उसको आउटपुट कर देगा. ठीक है, तो हम लोग क्या करेंगे ना, यहां पर हमें क्या करना पड़ेगा? वी हैव टू फर्स्ट ऑफ ऑल, because we want a recursive function, so we want a recursive function. Okay, so we will take a recursive function and we will take a value. So recursive function में वो नोड की वैल्यू प्रिंट कर देगा. We don't want, okay, we have to, I think, output the value. So let's have a int here. Okay, now यहां पर क्या होगा कि let's call it kth recursive. Okay, first of all, we will have the root here, we have the value K here. No, उस कंडीशन से नहीं होगा, because we want recursive ना, and C में हम लोग काउंट करेंगे. ठीक है, first the base case. The base case was this, that if root is null or if C is greater than or equal to K, in that case return 0. Else, guys, first of all, write subtree. First of all, make call for write subtree. So it will be kth recursion for the root right, comma K, comma C. After that, C will be increased. Now, guys, if C is equal to K, simply return the value of root data. And after that, do the same thing for the left subtree. So this is nothing but the in order, the reverse in order traverse. Okay. At the last, we will also call this function with root k and 0. Initially, the value of c will be 0. And we will return it. Let's compile it. Let's have a thing here, int c, and let's place a c here. Okay, we have got the right answer for it, for a given test case. Okay, let's submit it. Okay. Yeah, so guys, there is something कि यहाँ पर हमने इसको 0 रिटर्न कर दिया यार, which is not fine. तो इसके लिए हम लोग क्या करते हैं? इसके लिए हम लोग काम करेंगे कि जब हमारा ये c ग्रेटर हो जाए किसी वैल्यू के लिए, मतलब से ग्रेटर हो गया और हमें वो वैल्यू नीचे तो हमें रिटर्न नहीं करना पड़ेगा, ठीक है? तो हम लोग क्या करेंगे, यहाँ पर हमें बेसिकली स्टॉप करना है बट रिटर्न नहीं करना है कुछ, ठीक? तो लेट्स हैव यहाँ पर एक हम लोग आंसर ले देते हैं, ठीक? एंड इसको सिर्फ रिटर्न, इसको कुछ नहीं करते हैं, इसको वॉइड ले देते हैं और यहाँ पे रिटर्न कर देंगे. बट जब ये रिटर्न होगा ना, तो हम लोग क्या करेंगे कि उस आंसर में ये जो वैल्यू है रूट की, इसको स्टोर कर लेंगे एंड देन वी विल रिटर्न. लेट्स सी दिस थिंग आल्सो. तो थोड़ा सा है कि जो हमारा बेस के साथ तब वो क्या रिटर्न करेगा, एंड यहाँ पर हम लोग इसको कॉल करने के बाद में ना वी कैन रिटर्न द आंसर. सो मैंने बंद कर दिया, अदरवाइज मैं देखता कि रॉन्ग कहाँ पर हुआ था. चलो कोई नहीं, लेट्स रन द गेम. ओके, या दैट वाज द ओनली केस एंड वी हैव गॉट, हाँ बुलियन, इट्स फाइन, ऐसे कर लें, ठीक है, फाइन. दिस इज हाउ वी हैव सॉल्व दिस प्रॉब्लम. This was the basic approach. So today we have solved problems. We have basically focused on a topic called binary search tree. In the first 10 to 15 minutes, we have learned what binary search tree is. Then for next 10 minutes, I've solved a problem which is this, nothing but search in a binary search tree. Then we have solved a which is check whether a binary tree is binary search tree or not. At the last, we have solved a very amazing problem based on in-order traversal, which is nothing but kth largest element node, or you can say node in a binary search tree. That is what we have. Okay. So I hope this particular session is helpful for you. Guys, please don't forget to drop a comment after this session. How was the session? Have you learned something new or not? So please, yeah, like कर दो. First of all, please like this particular session. And just after the session, आज का POD मेरा नहीं आने वाला है, किसी और का आएगा. ओके, great शुभम. Yeah, so please write these amazing comments in the comment section. तो जैसे ये वीडियो खत्म हो जाएगा, after this session is ended, okay Rohit, because some of the English viewers are also here, but मैं हिंदी में बोल लेता हूँ, ठीक है? तो आपको प्लीज कमेंट में जैसा भी जो भी फीडबैक हो सेशन के लिए आपको लिख देना होगा. ओके, ग्रेट गाइस. Thank you very much for joining this session. Let's meet with the next session again tomorrow at 10 p.m. only. Okay, and just continue this journey of 30 days code. I think that some 6 days or 7 days are remaining. So let's complete it. Okay, thank you very much, guys. Thank you very much for joining. Have a nice day. Okay, and please don't forget to drop, I don't know for tomorrow Subham, maybe मुझे नहीं पता अभी कौन लेने वाला है. Okay, So yeah, please don't forget to drop the comment after this session that how was the session. Okay guys, and thank you, bye bye, have a good day, good night, happy coding. GFG कर लो, हो जाएगा.